This video was brought to you by the ILC. Welcome back to our Exam 1 review series. This time we'll be doing problem 3. In problem 3 they give you this picture with a rational function. You can tell it's a rational function because it has both vertical and horizontal asymptotes. The vertical asymptotes are the yellow lines going up and down, and the horizontal asymptotes are the horizontal lines going left and right. In this problem, we are asked to find the domain and the vertical asymptotes. To find the domain, let's look to the x values. And let's draw a picture of a number line with negative infinity on the left, positive infinity on the right, and we'll put a marker for 0 in the middle. Now the vertical asymptotes will interrupt the domain. So let's look for our vertical asymptotes on the graph. We have a vertical asymptote here at -2, so we'll put a dotted line there. And then we have another at +2. So those vertical asymptotes will break our x values into 3 regions: A, B, and C. Region A will go from -infinity to -2. This will be our first region in the domain. We'll use parentheses for both of them because infinity is not a number, and then asymptotes are not included. Now for region B, we look at the beginning of region B is the dotted line on the left, that's -2, and we go to the other dotted line, which is +2 here. So we'll say -2 to 2. And now another union because we have a third piece coming, that's PC. PC goes from 2 to infinity. That gives us our domain. Now for our vertical asymptotes, we must give a letter and a number. And for vertical asymptotes, we will always use the letter x for these because the x values are what we've cut out of the domain. So we'll say x equals -2 is our first vertical asymptote, as we saw here. And our other x asymptote is +2. And so this is how you represent vertical asymptotes. The letter x equals, and then the number for that asymptote. Next, the question asks us to find range and horizontal asymptotes. We can see we have a line going left and right, this yellow dotted line, at +3. Now for the horizontal asymptotes, we're going to use the letter y. And we'll say y equals 3 is our horizontal asymptote. Now for range, we want to start at the bottom and work our way up. So at the bottom we have a down arrow. And the down arrow will represent -infinity. So we'll begin by saying our range begins at -infinity. Let's follow that piece upward. Here at the top of this piece, we have this closed circle with 0, 1. Now remember, for range we are using y, so the highest that piece goes is +1. So we'll say -infinity to 1. And since it is a closed circle, we use a square bracket. Now we go up to the next piece. We'll say union to show there is another piece coming. And now let's look to this piece on the left. The lowest it goes is +3, which is what we labeled this asymptote with. But it doesn't actually touch +3. This is going to go next to 3, but not touch. So in this case, we will use parentheses to represent that 3. So now let's follow that piece upward, starting from the bottom, working our way up, and we have an up arrow. So for the up arrow, since we're pointed straight up, it's going to continue up and up and up off to infinity. So we'll say 3, infinity for the second piece. This will represent our range. So now we have the horizontal asymptote y equals 3 and the range negative infinity to 1, union 3 to infinity. The final part asks about the end behavior of this graph. The first part of this question asks, as x goes to negative infinity, what happens? If you see this symbol saying x, an arrow, and then negative infinity, that means we look on the left side. And then, once you look on the left side, we ask, what is the y doing? So as we go to the left, we see our graph is approaching positive 3. Now, it's not going to touch the positive 3, but it does go toward it. So we can say that y goes to 3. Or you can also say fx goes to 3 if you prefer that notation. But they both mean the same thing. So we could say as x goes to negative infinity, fx goes to 3. Now, let's look at the other piece. As x goes to positive infinity, what happens? If you see x going to positive infinity, we need to look to the right side of the graph and see what's happening to y. So now, on the right side of the graph here, we see that this end of the graph is still going toward positive 3. It's not going to cross that dotted yellow line. So we can say fx is still going to 3 on either side. Now, when you're asked about the end behavior, don't worry about any of the things going on in the middle. In this graph, our graph runs along that horizontal asymptote of 3 on both sides. Thank you for watching. We'll see you again soon.